But more importantly, we have some incredible partners in the room today. So Tony at Nicolay Plastics is with us. We've got Kevin with Diversified, and I would welcome you guys to come and talk to any of us. I have parts for you to see, touch, and feel. Additive is no longer prototyping. We're moving to producing, and we'd like you to join us in this adventure. Thank you.
So we're going to take a few minutes to ask some questions. Jeremy, is there anything new this year in additive that's really make you go, wow? You know, like I know you go to AMA, TC, Rapid, which are the big shows here in the U.S. We definitely encourage everyone to try to attend. So what made you say wow?
So I had two things in that category that I thought of. The first one was the UltraSim, the video that we showed. That technology and being able to utilize that on the toolpath level, on a layer by layer level, to be able to predict results in printing, that to me was absolutely astounding, because it takes so much of the guesswork out, and it's really one of those things that's moving additive manufacturing into actually manufacturing. So right now additive is at last year at AMUD we had I'm taking a tangent here, but last year at AMUD we had a keynote speech by Todd Grimm, industry consultant, and he basically said, shame on all of us for calling it additive manufacturing. There's nothing manufacturing. Everyone in this room has tightly controlled processes, and you know what's going to happen with a piece of equipment from day to day to day. Additive isn't there yet, and UltraSim is one of those things that's helping move us in that direction. The other thing is the strides we've made in the last year on serializing, for doing serial production, just exactly what Lisa's talking about. I know the guys at BD as well, and what they're doing is incredible. There's also a lot of other folks, like Densmore is doing great stuff there too. So those two things for me.
Okay, thank you. Lisa, what kind of injection molding parts, right? You talked about the Vitamix. You think that are a good fit for additive?
I think, depending on the size of the business, the molder that I worked for was turning away business that was anything less than 25,000 pieces. And so what I think we really have to start thinking about is taking a look at our business and saying, what are we turning away and why? And if we can find an additive process that can help us take those opportunities, maybe there's higher margins, because we know those that use low volume are willing to pay a little bit more, or maybe it's even a piece that you're just having consistent problems with and maybe due for a redesign, or maybe it's even that you're having problems with whoever's doing your tooling and you're not doing it in-house. So I think there's a lot of different ways to look at those opportunities, but again, it just depends on how it's designed and if the end-use customer is agreeable to a redesign for additive.
Great, thank you. Dan, I know you do both metal and plastic. Where do you, I've been really reading a lot. I would encourage everyone to get as many e-newsletters as you can. And you do both metal and plastics. And I've just been really impressed with metal and what they've been able to do. I know this is a plastic organization, but, tell us, what's good for plastics, what's good for metal? Because I'm sure some of these shops, everyone might do some CNC,
sure.
Some other thing.
There are really two families of metal 3D printers. You've got the traditional DMLS, which is a powder-based, big, $500,000, $1 million machines with a special building, setup to run those, and there's a lot of environmental concerns, and the operators have to wear spacesuits and all that kind of stuff. So that's the one end, and that's sort of what has historically been metal 3D printing, and certainly they can produce some fantastic parts. Over the past couple of years, we've had companies like Mark Forge and Desktop Metal, which have come out with more office-friendly machines that get away from the powder-based printing platform and going more towards a filament where there is no exposed powder all the powder is bound. And so you don't have any of those environmental concerns. The machine can run in an office environment. And also at a much lower price point. So under about $200,000 now you can get into a metal 3D printing system. So I see there's a lot of upside for that level of machine, where it's going to become a little bit more accessible for smaller companies to bring that technology in-house as opposed to the $1 million machines.
Yeah, and I know you have big rep. I've seen some of the parts. I mean, how big is?
So with the big rep, the machine that we have in-house that we sell and use for our services is a meter by half meter by half meter, and that's the small one. The manufacturer actually has machines that go to a meter cube. So pretty large parts that we can fabricate.
Yeah. Have you seen the growth in that compared to the smaller parts or not?
Certainly we get a higher demand for a larger quantity of smaller parts.
Okay.
But there's always those few applications that if you want to do a dashboard for a car, or we do a lot of work in medical with companies that are developing medical simulators. So we're doing medical mannequins and large piece parts like that, which on traditional machines would either be too large or much too costly.
So Steve, what's been the biggest challenge? I mean, you bought your machine, a while back, and I thought it was great that you wanted to jump in and give it a try, because we had talked about it. I can remember visiting, doing a tour of your plant, and you talking that you wanted to do it, and you bit the bullet and did it. So what's been the biggest challenge? Is it convincing customers, or getting the staff on board, or something else?
Well, the biggest challenge with the industry is it's constantly changing. The materials are changing, the equipment is changing.
Yeah.
Certification is now starting to play a big role. How you certify whether it's metal parts or plastic parts. So we're just particularly someone like a Venture Plastics, jump in, and so you just kind of do it. I would recommend though that because it's always changing, and we've mentioned the technology house that Carlin works with, they're just on the east side of Cleveland. Start with the service bureau. Start with someone that already has that 25 years of experience like the technology house does, and have them guide you as far as the equipment, the material, and then if you have enough critical mass, you can step back and buy into it. Do an ROI on that, and you do have to. We've touched on it during the conference. You have someone who's passionate within the organization to drive additive manufacturing if it's new. Get some of the young kids that have the passion and love to have that.
Yeah. So we have a couple of questions. Let's see, regarding the BASF part, so this is for Jeremy, in which the optimization software was used, did the software automatically determine and place the void core outs in the part?
Do the core outs in the part?
Yeah, it says core out, void core outs in the part.
Yeah, okay. Yeah, so the answer to that question is yes. So a piece of the UltraSim software is topology optimization. So what he was talking about when he was holding that, which was funny, it's like big word, the elbow. That always makes me laugh. But when he was holding that elbow, was so a piece of it is the difference in the design area, so the allowable area where the part can exist, and then what's actually needed for the part. So yes, the software did the topology optimization to actually go through and remove those pieces of the assembly that weren't necessary either for strength or for function.
Yeah, and what's the biggest hurdle additive manufacturing has to overcome before it becomes, across the board, let's see, become more mainstream? That was the word they used. Why doesn't everyone take, a shot at that, short and sweet. You start, Lisa, yep.
I would say, really, being that I've done this for the last 10 years, I've always kind of seen it as just 3D printed. It's this cool word. It's this thing that's been going on for over 20 years. But we've got to get past that mindset and be relevant with where today is going. And I think if we don't do this now, as fast as things are changing, we are going to get left behind. Because every molder has almost the same things, right? You want high quality parts that meet and exceed customer expectations. But you've got to stay relevant. And how do you do that? Is bringing additive to the forefront, having passion behind it, and being able to set yourself up different from your competitors. And we have not done a really good job because people just think prototyping is just that. Get into producing, look at what production can be like in low volume applications.
So I see more adoption in additive when a few different areas are addressed by the manufacturers. One is going to be overall ease of use, as far as not just printing the part, but all the post-processing that happens after that part comes off the machine, and that certainly varies from manufacturer to manufacturer. But we kind of refer to that as the dirty little secret of 3D printing. Here's a nice machine in the showroom, and the part, well, it's done, but it's not done. It has to go through these, extra steps, and we have those other machines hidden in the back. So there's that. Materials, strength, and properties is another area that things need to improve. Because historically, if you look at processes like SLA, the parts coming off the machine were, they were beautiful but very, very fragile. Or on the flip side, you have, the opposite process like FDM, where the parts might be much stronger, but you don't have the same surface finish and quality as you get with the SLA. So a marriage of those material characteristics would probably lead towards more adoption of the technology.
How about you, Steve? Your
Well,
thoughts?
just give the youth today that is passionate about 3D printing programs. This is a message to folks like me, the senior engineers and the senior management. Go ahead and sign off on their projects. Let them go ahead and press on. Give them the confidence. Don't let it sit on your desk. Let them get rolling, because it's here, and we're going to see. As I mentioned, Venture Plastics is 50 years old, but in another 10 years, we'll probably have as many 3D printing machines on our floors as we have injection molding machines. You're seeing that, just be a natural transition from 3D printing manufacturing to injection molding. So it's going to be a transition, a big transition.
Yeah. That's a big visual,
Yeah.
right? If you think about, walking in your plant and all of a sudden you have 3D, additive manufacturing is half your business. And to me, that blows my mind. Anyways, Jeremy.
So I agree with what I've heard thus far, obviously, and rather than parrot that, one last thing that I would like to do is flip it around and say, what's the biggest challenge that you folks in the room have as far as additive manufacturing goes? And I think we're starting to see OEMs investing heavily in 3D printing because they're seeing an opportunity to cut out your customers, to cut out your tiers. And that's maybe something I shouldn't be saying up on stage, I don't know, but it's something that I see every day. And I see the tier ones, not responding. OEMs are digging in. And so, to Steve's point, get involved and get in there, and we're seeing companies that are positioning themselves to be the new tier ones. And they're gonna help OEMs. They're not gonna be selling to the OEMs. They're going to help OEMs. They're going to partner with OEMs. And I think that's the new paradigm. And to what everybody else said, especially you, Steve, dive in, figure it out. It's got to start somewhere. It's got to start with an application somewhere. So.
Well, thank you, everyone, for attending, and give everyone a applause.
At this point, we have a chance to get up and talk to each other again. as like yesterday, we're going to have a series of small group discussions, but today we're going to talk about workforce development